Hi everybody. We have piecewise functions, which we're going to revisit, and the thing we're going to just add one more thing to it is we're going to talk about the domain and range of piecewise functions. Now, definition: a piecewise function is a function that is written using two or more expressions. Now, definition of domain: the values x can be. That's all that is. These are the possible values for x. The definition of the range: the values y, or we also use f of x, the values that they can be. All right. Now, I've got some examples following. We're going to graph the piecewise functions, and we're going to identify the domain and range. That's our instructions. If you recall, I think you have notes on this. You can go back to those also. Our steps: we draw the vertical lines, we make our tables based on each expression and actually kind of the domain of each part, and then we draw graphs from those tables. So, idea here is, I think I'll do an example. I'll leave one for you to do. Then I'll do another example, and I'll leave one for you to do, and we should be done for the day. So, f of x, so I have three expressions. F of x equals -3. I got another expression, f of x equals x, and f of x equals -x plus 6. So I've got three expressions that f of x equals, and it all depends on the value of x. If our value of x is less than or equal to -4, we're going to use this expression. If our value of x is greater than -4 but less than 2, we're going to use this expression. And if our value of x is greater than or equal to 2, we're going to use this expression. So, and I apologize for not having graph paper. So we're going to have to just draw it out here. Try to make it somewhat even on the spacing between your tick marks here. Okay. So, I said, first of all, let's make the vertical lines and the first vertical line we want to make is at -4. I'm using my vertical lines here. X is -4, 1, 2, 3, 4, this way. So I'm going to make, and I'm not going to make it real prominent. This is not actually part of the graph. This is just a boundary line to help us make the graph a little better. And if I do it here when x is 2, got another good place here. All right, so I'm kind of in three sections here. Now, I'm going to make tables, and the first table will go with this first expression that f of x equals. I'll just use y instead of f of x, but it's when x is less than or equal to -4. So -4, to go less than -4, we go -5 and then -6. I'll just do that. But every time, well, no matter what x is, there's no x over here to multiply by -3 or anything. It is just simply -3. So I'm going to make the table. Now, this is less than or equal to, so I'm going to use a solid dot. So at -4, -3, 1, 2, 3, I'm making a solid dot here. And then -5, -3, -6, -3, the first piece of this function is right there. Now, the second piece is from -4 to 2, and that's not too many, so I'm just going to write down -4, -3, -2, -1, 0, 1, and 2. That's more than I thought. But y for this is equal to x. Well, if x is negative 4, then y is negative 4. If x is negative 3, then y is negative 3. And this is negative 2, negative 1, 0, 1, and 2. The thing I want you to notice here, though, is these are not underlined, these inequalities, so we will use an open circle at each end from 0 and 2. So I'm going from negative 4, negative 1, 2, 3, 4 down here, and putting an open circle, and then negative 3 is right here, negative 2, negative 2, negative 1, negative 1, 0, 0, 1, 1, and 2, 2 is the end of it. It gets an open circle. So there is that piece of the function. And then the last piece, and this is y equals negative x plus 6, but it starts at 2. It's going to get the closed circle. And then bigger than 2, 2, 3, and 4. Let me just do those 3. Now negative x plus 6, so negative 2 plus 6 is 4. Negative 3 plus 6 is 3. And negative 4 plus 6, lost my train of thought there for a second, is 2. So 2, 4, 2, 1, 2, 3, 4 is right there. There's 2, 4. 3, 3 is right here. 4, 2 is right here. And I can go 5, 1. I know it's going to go through there. So I'm going to draw this. Okay. Whoa, it went out of focus there, didn't it? Now, the domain and the range. The domain. If you'll look, we get to this negative 4. We have a solid dot at negative 4. Up here we have a solid dot at 2. So from left to right, there is no limits. So the domain is all real numbers. And another way we can do that, the far left of the domain is negative infinity, and the far right of the domain is positive infinity. Okay. The range is going to be different, though. That's up and down. Domain is left and right. That's what I was looking at. Now up and down, there's nothing down here. There's nothing down here. There's nothing below this. What value is that? That is that one right there, negative 4. There is nothing below negative 4. And it kind of goes up, hits all these values, and it hits values here and values up to here, but it does not go above this one, 1, 2, 3, 4. So y is less than or equal to 4. Y is less than negative 4. Y is greater than negative 4 and less than or equal to 4 is the range. Now another way of writing that in interval notation, we'd have the negative 4 with a curved bracket and the positive 4 with a square bracket, because it's included. It's got the solid dot. Negative 4 has the open circle, so it's not included. All right, there's example 1. I want you to take some time and do example 2, and it's right here. You can pause it, work on that one. All right, I have example 3 here, and I will do this one. So we're going to graph first. well, I'm going to make the graph first. Okay. I'm already regretting where I started this here, so I'm going to move this over. Actually, I'm going to do it right here. I'm going to do it on this piece of paper because I want this more centered. Okay, just make your tick marks. Like I said, try to keep them fairly even. And we are going to draw our vertical lines. -6 at -6. 1, 2, 3, 4, 5, 6. At -6, we're going to draw vertical lines. And from -6 to 2, 1, 2, we'll draw a vertical line at x equals 2. And then at x equals 4, so we're going to have a gap here. And that's got implications for the domain also that we'll talk about here in a little bit. It's easier to talk about domain when you looked at the graphs. So now I'm going to make the tables. And for f of x equals 2x, I'm using y, right? It goes -6 with a solid circle. It's going to be a solid dot, the -6 whatever point. And it gets bigger. -6, -7, -8. Not bigger. Those are smaller. It gets less than or equal to -6. And 2 times -6, that's -12. 2 times -7 is -14, and 2 times -8 is -16. All right, so I'm going to graph that. I may have to extend this down a little bit. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So that's how far I'm going to go down. I'll just kind of draw this boundary line here also. So -6, -12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we said that gets a closed circle. And then -7, -14. I'll go down a couple here. And -8, -16 is like right there. So this part of the line, can you see that at all? I wonder if that was, this part of the line is here. Now, the second part is from -6 to 2. I'm going to just skip some. Now this gets an open circle, right? This is the x and the y equals 5. So that's going to be an open circle. I'm going to go -4, -2, 0, and 2. So I'm just going every other number here, the evens here. And this one will get a solid number, but it's 5. No matter what x is, y is always going to be 5. So that's going to be another of those horizontal lines we've been dealing with. So -6 is right here. 1, 2, 3, 4, 5 right there. -4, 5 is there. -2, 5 is there. 0, 5 is there. 2, 5. And, oops, okay. Can we kind of backtrack? I can't erase that, but that's an open circle, not a closed circle. If you have a pencil, you can erase that. That's why we do math in pencil, isn't it? Okay. So there's that middle part. That's the middle expression. Now the last one is -2x plus 1, but that starts at 4. See, x is greater than 4. Let's go bigger than 4. 4, 5, and 6. So y is -2x plus 1. Notice with my table, I make it to match these constraints here, these inequalities. X is greater than 4. Let's use 4, 5, and 6, but I'm going to have an open circle at 4. And negative 2 times 4 plus 1, that's negative 8 plus 1 is negative 7. Negative 2 times 5 plus 1, that's negative 10 plus 1 is negative 9. And negative 2 times 6 plus 1, that's negative 12 plus 1 is negative 11. So let's put in 4, negative 7, 1, 2, 3, 4, 5, 6, 7. 4 negative 7s right there. Extend these a little bit. We'll do 5, negative 9, be right around there, and 6, negative 11, and then it just continues right through there, kind of like this. So there's that part of the graph. Now domain and range, that's going to be interesting here. Domain, and I'm going to try it with all interval notation. The left, it'll keep going left forever. So I'm going to go from negative infinity until this is an open circle, but we're already to here. But our gap, see this gap right here? A left to right gap here. We got to deal with that. So I go negative infinity to 2. And then when you have a gap like this, I put a little u here. And it picks up again. And actually, with the 2, I'm going to put a square bracket because of the solid circle. And I'll put an open bracket here at 4. It picks up again at 4. So this kind of lets us jump to 4. And then it keeps going down and right forever. So we'll go to infinity there. So if we can, we'll try to clear that up. If that's not clear right now, the range, it'll go down forever. So it goes from negative infinity. And then it kind of goes up to here. You can kind of go over here, and it'll go up until we get to that negative 7. And then it will, I've never had one do this before, but it just goes up to 5. So I may just put that in brackets like that, but 5's the only value there. It doesn't go up higher or lower. It stays at that constant 5 in between these two. So these are the values that y can be. Anything from negative infinity, negative whatever, up to negative 7, and the number 5. That's the values y can be. All right. Now that takes a little time. And that was example 3. And I want you to finish this work by trying to follow that and do example 4. You guys have a wonderful weekend. Get that uploaded in PowerSchool and be done with math for the week. I will see you Monday, hopefully.